This is the intro to triangle similarity, how to prove the two triangles are similar and kind of what that means. So first up, what exactly similarity means. Two triangles are similar if they're the same shape but different sizes. Specifically, that means that they have to have all of the same interior angles and that the ratio of their corresponding sides is the same. A lot of words there. I'll show you what that means. The ratio, quickly, is when you divide one by the other, and corresponding means that you're comparing the ones that are in the same relative position. So for example, triangles ABC and DEF are similar, and here's why. So first of all, if you look at the angles, triangle ABC has interior angles 25, 35, and 120 degrees respectively. DEF has the same angles, 25, 35, 120. The other thing is that these side lengths, 7, 8, and 12 centimeters respectively, though they're not the same as the side lengths in DEF, the ratio of the corresponding sides is the same. So here's what I mean by that. So if you look at this, let's say 14 centimeter length, which is between angles 120 and 35. If I look over here between angles 120 and 35, the side length is 7. When I compare 14 to 7, the ratio, when I divide them, is either 14 divided by 7, which is 2, or 7 divided by 14, which is 1/2. It doesn't really matter how I compare them. All I want to know is that the ratio of all the corresponding sides is the same. So as long as I'm comparing them consistently, that shouldn't matter. Next up, between, let's say, the 35 and the 25, which here is 24, between the 25 and the 35 here is 12 centimeters. And the ratio there is 24 divided by 12, which is 2, or 12 divided by 24, which is 1/2. It's the same as the other side that I checked. And the final side, the 8 and the 16, has a ratio of 2 or 1/2, depending on how you reduce them. And so that is the same ratio for all three corresponding sides, each pair. Another way to look at that, if you didn't know the angles, I said, for instance, when I looked at the 14, I said look between these two given angles, between the 35 and the 120. That's the relative position. But another way I could have looked at that was that the 7 centimeters is the shortest of the three sides in triangle ABC, and 14 is the shortest of the three sides in DEF. So corresponding means that they're in the same relative position. It also means that they're the same relative size. So these two are similar. They fit those two criteria. Just like in congruent triangles, equal angles don't have to be shown with the numerical angle. They can be shown with symbols. So for instance, these two are the same because they have the same indication. These two have the same indication. These two have the same indication. And also, like in congruence, it's possible to prove the two triangles are similar even if you don't know all of the information about them, meaning all three angles and all three side lengths. There are three sets of minimal conditions, just like there were for congruence, and they're almost the same as for congruence as well. Here they are. One is that you have all three side lengths, and they all have the same ratio. Another one is that you know two sides and the angle between them. So the two sides, the two pairs of corresponding sides, have to have the same ratio. The angle between them is the same. Or if you simply know the two angles are the same. I'll take you through why that is and kind of what that looks like really quickly. First, all three side lengths. So if the ratio is the same, it forces the angles to be the same too. And how would you check that if you didn't know the angles? Well, we kind of mentioned that earlier. It's that when I'm comparing these, I'm comparing the same relative sides. So I would look for, let's say, the longest and the longest of the three sides in this triangle, and the longest of the three sides here. I will tend to, when I check the ratio, put the larger number on top, just so that I don't end up with a fraction. It's a little bit easier in case it's a not so great fraction. So that ratio is 2. When I check the two shortest sides, 4/2 is also a ratio of 2, and the middle sides work out the same. It's tough to tell here, but these angles are forced to be the same. This angle here between the 4 and the 5, blue and the green, is forced to be the same angle as here between the blue and the green. And same for the other angles too. So that's one of the three minimal conditions. And since that ratio is the same, they're similar. The next one, SAS, meaning if you have the ratio of two side lengths and the angle between them is the same. So what I did here was I said, suppose we go halfway. That meant that I picked a ratio of 1/2, though this would work for any ratio. If I went halfway down this side length, so till about there, I kept the same angle, and I went halfway down this side length. So that ratio, the red goes halfway down this side, the blue goes halfway down this side. Even if it doesn't look exactly half, I use the measure tool, so it is, you can trust me. If I connected the third side, that third side ends up being 1/2 of this length, and kind of importantly for proving that they're congruent, it also works out to be parallel. And you can sort of see that these two lines, the green one and this third side of this black triangle, those are parallel. And the fact that they're parallel means that the angles are the same as well. So SAS is another minimal condition for congruence. And finally, if you have two angles, that's sufficient. Mathematically, since we know that all three angles in a triangle add up to 180, once you know two angles, the third one has to be the same too. But I'll show you why that works out to make a similar triangle. So if I took a random side length and call that A prime and B prime, so that's like the same relative side here. If I cut this angle, I sort of like took a screenshot and copied it, so I know that it's the same angle. I just placed it over here. I overlaid it there. And if I did the same thing, let's say here with this angle, so if I extended these lines, so I know that those angles are the same, they end up meeting at a point such that if I overlaid this angle, that would fit perfectly on top as well. So the angles, the third angle ends up being the same, and the ratio of those sides ends up being the same as well. Those two end up being similar. So that's the intro to what similarity is and what the three minimal conditions are. And there is another video lesson on what types of questions you can see.